Hi, welcome to my series of solid mechanics. In this series, I am planning to cover all the fundamental aspects and provide a deep insight into the solid mechanics subject, eventually leading to theory of elasticity and finite element analysis. A very quick brief about me. I completed my bachelor's and master's degree in aeronautical and aerospace engineering. Having worked as stress analysis engineer for the past 12 years, I am at the minute working as senior engineer with Rockwell Collins. Let's move on and get into the subject. As you all know, engineering mechanics is broadly classified into rigid body mechanics, solid mechanics, and fluid mechanics. As the name indicates, rigid body mechanics is the study of rigid bodies, and solid mechanics is the study of deformable bodies. So what is the fundamental difference between a rigid body and a deformable body? A rigid body is one which does not have any deformation nor a relative displacement between 2 points on the structure, whereas a deformable bodies is one which has deformation, relative displacement. Example for a rigid body is a goods carrier which is standing on its own on the railway track. What happens if someone pushes it from one end? It's going to move unless there is going to be a resistance from the other end. So it's clearly a dynamics problem. It's going to be a rigid body that is on uniform motion. Whereas a simple example for the deformable body is a bar attached to the wall or a structure which is clamped at one end and the load being applied to the other end. Here you see the reaction force which is being developed at the point where it is attached to the wall and the internal stresses developed. Why we need study solid mechanics? Solid mechanics is very important and helps us to design the structural member. It helps us to analyze the load behavior of the structure, to do stress strain assessment, to do deflections and deformation assessment, strength of the material, to find the factor of safety, and eventually helps us in predicting fatigue life and fracture of the material. Thank you for watching for this introduction video. I hope this will be helpful to understand what I'm going to speak in the consecutive series. Keep watching. If you like my video, please do press the like button and keep watching my channel. Thank you very much.